Robin Higgins, and this is How to Write Oxidation States in Mastering Chemistry. Okay, so let's go over the rules for assigning oxidation states. There's a few that are always true and a few that are generally true. Okay, so 1, the oxidation state of a free element is 0. So what that means is that you just have an element by itself, not bonded to anything else. Its overall charge is going to be 0. So if you just know that you have 1 helium, its oxidation number is going to be 0. If you have N2 floating around by itself, overall, it's going to be 0. All right, next rule. Hydrogen is usually positive 1. This is a pretty good standby rule. So if you have something like hydrogen chloride, you know that hydrogen is going to be +1, and so you can deduce that chlorine will be -1. Next rule, oxygen is usually -2. The exception to this is peroxide, which is O2, which has a charge of -2. So oxygen is -2, except when it's O2, which also has a charge of -2. Next rule, halogens are usually -1. So back to our example up here, chlorine, a halogen, was -1. And that's usually the case, although sometimes this one will get broken. The first 3 are pretty much always true. And lastly, the sum of all atoms in a molecule is whatever the total charge is. Basically, everything has to add up. So if you have a long molecule, you have to be able to add up all your oxidation states, and that has to be the charge of that molecule. So if you just have a regular molecule, let's go back to our example of hydrochloric acid. We know that this charge is 0 because we don't have a formal charge, which would have been represented here if there was one, but there isn't. So we know it's going to be 0. So this means that when we add up both of these elements, the overall charge has to be 0. Remember, we assigned hydrogen +1 and chlorine is -1, and this equals out to 0. So that's what that means. Just check your answers. Let's go over a couple of examples. So 1 is iron oxide. So remember, iron isn't in any of our rules. So let's start with oxygen, which is, well, there's 3 oxygens, and we know that each oxygen is going to be -2. So this means that oxygens in total are -6. And there's only 2 irons, and we know there's no charge on this molecule, so we're going to have these 2 irons add up to a total of +6 to cancel out this -6. This means that the total irons are +6, and since there's 2 of them, each one has to be +3. So our oxidation states are +3 for iron and -2 for oxygen. One more example. Let's say we have something that has a charge. So PO4, -3. Now we know that when we add up all our oxidation states, we have to be able to get something that's -3. So back to oxygen, that's 4. So that's going to be now -8. And we know that it's going to overall be -3, which means that this phosphorus must somehow have a charge of +5. And so that is how we add. Now we add them up, and we can see that we do have -3. So oxidation states +5, -8. I'm Robin Higgins, and this has been How to Master the Oxidation States of Chemistry.